and the right. Are these the same values? No. So the limit does not exist. It
Okay.
has to be the same from the left and the right.
Okay.
Okay. It has to just approach the same value. It doesn't necessarily need to be the same value, it just has to approach the same value. So let me grab the graph one more time here. So we're up to the next grouping of questions, which is where it says find f of 1. F of 1. That means like, what is the function at 1? Well, this right here is f of 1. X is 1. It's just asking for the y value there. So that is 2. Y
Okay.
value of 2. Is that clear? So the limit from the left, limit from the right, and the function are all different. All right, now this is now asking for the limit as x approaches -1, -1 from the left, which is a little bit odd, but that's what it's saying. This negative top right means from the left. That's -1. So we're going back to the graph here, and I'll do this in blue. We're looking at -1. Oh, why are they going? Oh yeah, that's -1. So they're asking, what's the y value there? What's the y value from the left that it approaches? And it looks like the y value that it approaches is 5 from the left. Okay, so that's what this notation means. From the left, y value of 5.
Okay.
From the right, this means -1 from the right. So you go to that same place, but now you're approaching it from the right. What's the y value there? It's +5.
Okay. So
So
there's,
this time it does exist, and it's the same value. It's 5. Sorry to interrupt you.
oh, no, you're fine. Okay.
Okay. You will get a question like this on your test. This is kind of a standard, um, test question.
Okay.
All right. And then the last one for part 4 is just to evaluate the function at -1. It's like, what is the output when x is -1? Well, if you go back to the graph, it is still 5.
Okay. So they're all five. Those last four are all
Yes.
five. Okay.
Yes. Which isn't unusual. And it's because it's continuous, because the graph just is nice and continuous. They're all going to be the same. They will all be the same.
It's easy enough.
Okay, next question here. You, I can't remember. Did I ask you what kind of calculator they're going to let you use on this?
Yeah. I'm pretty, to my knowledge, it's everything but the TI 89 or the one that, you can like
Okay.
download and stuff.
And do you have a TI 8384?
I do, yeah. Let me find
Okay. So the way to do this problem, it says to complete the table. They're giving you the x values, and you have to put these x values into this function here. Now there's kind of a shortcut here. Do you have your TI 8384 handy?
I actually think I left it at home, unfortunately.
Okay, no problem here. I'm going to quickly show you this because I think it will help. Give me just a moment to pull up mine, and this will save you some time on the test. All right, so the standard way to do this is to go to your calculator, and that's pulled up here. I'm not going to see my. The standard way to do this is to just put the number in, like 6.9 minus, I'm sorry, 6.9 cubed, minus 343 divided by 6.9 minus 7, close parentheses, and hit enter. All right. So that's the first box. I'll just
Okay.
144.91. The problem is that you have to remember to put parentheses in, of course. That's kind of important here. Now, this is not to get too programmatic, but the better way to do it is to do 6.9 and hit this STO button. And what that does is it says X is going to be 6.9. Okay. And then instead of writing it each time, you're going to go back and type in X cubed minus 343 divided by x minus 7. And the calculator now knows to use that x value in there.
Okay.
So you're going to see we get the same result. Now, why would you do this? Well, because we can quickly change the x value. We can store it STO, store it back to x. And then if you hit second entry, you get back to this value, this equation again. And so it's a way to more quickly do the calculations.
Okay.
Now, you don't have to do this. You can go back and enter it each time. Totally up to you. It's just that it is kind of slow to keep entering it every time.
Yeah, that's a lot
So,
easier.
so I will leave that up to you. I never use the calculator because it's like walking and you can drive. I'm going to do it another way here where it's kind of similar, but I'm going to just save some time here and get you the answers
Okay.
for this. But any questions on like how to enter this or anything like that? Because you do tend to get a problem like this on the tests.
No, I can do that. I think that's
All right, 146.98. No, 3 decimal places. 979. So that's this one. That's this one. So this one is 147.021. 147.210. And 140. Really? 149? Wow. Okay. So the limit is like, to me, it looks like it's approaching 147. Like these numbers are a little bit below 147. These limits are a little bit above 147. I feel like it's approaching 147.
okay.
Any questions, thoughts on that?
No.
Okay. There is a better way to do these problems, which we see in the next one here. So let's say you were on a test and you didn't know what to do here. You would do exactly what you did in the previous problems. You would pick numbers really, really close to 4, like 3.9999, or however many you wanted in 4.00001. And you would hopefully see the result. Like you would figure out that it is 8. Okay. But there is an algebraic way to do it, which will show you as well. But if you're stuck on the test, you can do that. You have to factor.
Okay.
So the top is difference of squares. And anything that's the same on the top and the bottom cancels. Okay, so it's really the limit as x approaches 4 of x plus 4. And you can put 4 in for x. 4 plus 4 is 8. But like I said, if you were to put in these numbers, you would get like 7.99999 or 8.0001. You would get something really close to 8. And maybe you could just be okay with the idea that it's probably 8.
Okay.
Because you said you have to go do some sort of proctored thing for your
Yeah.
exams. Yeah,
I don't know if it's in person or an online proctor, but yeah.
right. I give you some options when you get closer to that for help, but the calculator is really going to help you a lot on
Okay.
these. I'm going to do my best to show you uh, that way.
Okay.
All right, next question here. Same idea. You could pick like a number really close to 144. And if you're wondering why I'm picking 144, it's this number here. Why I picked something close to 4, it's this number here, the limit. So you
Okay.
could pick like 144.0001 or 143.9999, so on like that. But there is a way to do it by hand. And because this one says integer or simplified fraction, we may find that that doesn't quite work, or you'll have to guess what the fraction is. So to do this properly, you have to multiply by what's called the conjugate. So the conjugate of the numerator is square root of x plus 12. And you have to multiply the top and the bottom by that. Now, why is it the conjugate? It's because of this change right here. The negative to the positive or the positive to the negative. Okay, now you do want to FOIL the top. but not the bottom.
Okay.
So when you FOIL the top, the square root of x times the square root of x becomes x. The rainbow method, if you like that. Square root of x times 12 is 12 square root of x. Minus 12 square root of x becomes minus 12 square root of x. Minus 12 times 12 is minus 144. Notice that the O and the I, in this case, cancel. These go away. They're opposite in sign. So what happens as a result, like the net result of all of this is it becomes x minus 144 on the top over x minus 144 on the bottom, square root of x plus 12. You only FOIL the top, not the bottom.
Okay.
All right. Now, when these cancel, when these factors cancel, what is left over on top? Like what's really written here that's not written? What's here but not written, if you remember?
Um, on the top,
Yes.
I don't know.
There's a one. There's a one that's still there. It's
Um,
not zero, it's one. So this whole thing becomes 1 over the square root of x plus 12, limit as x approaches 144.
okay.
So that's important to remember, especially if you're doing it by hand. Now, when you put in 144, you get 1 over the square root of 144 plus 12, which becomes 12 plus 12, which is 1 over 24. So the problem, that's the answer. The problem with doing the calculator stuff in the beginning is you're going to get a decimal and probably not recognize that it's 1 over 24.
Okay.
So this is one where if you get it, you will have to work it out or figure out how it works. Like you can almost figure out what the answer is from the numbers. You
Mhm.
can recognize, oh, uh it ends up being 1 over the square root of x plus 12 instead of minus 12. So you can maybe like pattern it if you want.
Okay.
It's up to you. Totally
Okay.
up to you. All right. Any questions on that before we move on?
No, just something I have to practice again.
Yeah. Yeah. Okay, I think we talked about this type of problem last time we met. The limit here requires you to expand this x plus h squared. And we talked about that you have to remember that this is really x plus h times x plus h. And again, you have to FOIL to expand it. So x times x is x squared, x times h is xh, h times x is also xh, h times h is h squared. This simplifies to x squared plus 2xh plus h squared. So if you had like a note card, if you're allowed a reference sheet, which I don't think you are in this class, but you might consider, putting that down there so you don't have to redo it each time.
Okay.
So the whole thing here, the whole thing becomes the limit as h goes to 0. Instead of that x plus h squared in parentheses, you rewrite it with the x squared plus 2xh plus h squared minus x squared all over h. And you see a cancellation. You're like, okay, the x squared cancels with that x squared, and everything left over has an h in it. So this becomes the limit as h goes to 0, 2xh plus h squared all over h, but you divide both of them by h. And so the h's cancel, and you get 2x plus h. And so the problem up to this point, and I didn't really address this, but if you were to, the reason you can't just like put the value of 0 in for h is because you end up dividing by h, dividing by 0, h is 0, dividing by 0, dividing by 0, dividing by 0. But finally, there's no more division by 0. And then now you put that value in for h. So it becomes 2x plus 0, which is just 2x.
Okay.
there's, again, there's maybe a shortcut for the test. I don't know if we should address that quite yet, but we can later on. And are we still good on the order? Like I haven't skipped any. We're
No,
still
not so far.
okay. Like hearing that. All right. So new problem here. So with infinite limits, this is an infinite limit. And forgive the language. I hope this isn't offensive, but there's wording here like is it top heavy or is it bottom heavy? Okay. And top heavy or bottom heavy refers to the exponent. So whichever is bigger.
Okay.
So in this one, I would call it bottom heavy. And bottom heavy just means that it's a bigger exponent on the bottom.
Okay.
When it's bottom heavy, it always goes to 0. So this
Okay.
just goes to 0.
Oh, all right.
Now, if it's top heavy, it goes to plus or minus infinity.
Okay.
And sometimes it's like well proportioned, we'll say, top and bottom are the same, and then it's something else. So maybe we'll get that example another one. But if it's, I'll just maybe make a note here. But if it's the same exponent top and bottom, and maybe I'll just make an example like 15x to the third over 25x cubed like this. This would be an example of it being the same top and bottom.
Mhm.
The limit goes to the ratio of the leading coefficients. And then you do want to simplify this would go to 3/5. If it does simplify.
Okay.
So those are the three cases that you might see.
Okay.
Yeah, bottom heavy 0, same top and bottom. Top heavy, it goes to either positive or negative infinity.
Okay. So bottom heavy is always going to be 0, and then top heavy is always
Always.
going to be plus negative. Okay.
Yeah. Yeah.
Okay.
Right. We got a new problem here. This is considered a piecewise function. There are 3 pieces. They are first asking for the limit as x approaches 4. So what that really is, actually, I'm going to pick a different snip to do this. That way it's more clear. It's just not clear the way it is. All right. In part A, it's asking for the limit as x approaches 4. And what that really is it's 2 things. It's the limit as x approaches 4 from the left and the limit as x approaches 4 from the right. So from the left is when x is less than 4. From the right is when x is greater than 4.
Okay.
So like to do this problem, you have to first recognize that for 4 from the left, you're going to use this one here. 4 from the right, you're going to use this one here.
Okay.
Right. And so to actually to do the actual mechanics of this, you have to put 4 into the first one, which becomes 4 minus 2, which equals 2. Let me actually put that here. And for the second one, for all x values, the answer is just 2. And then you ask, are these the same? And they are.
Mhm.
So the limit is 2, and we're happy.
Okay.
All right, for the next one, we're finding the limit as x approaches 7. So we're going to repeat this process. We're finding the limit as x approaches 7, which is really 2 things. It's the limit as x approaches 7 from the left, the limit as x approaches 7 from the right, which means that you're going to use this one and then this one. And you're putting the x value here. This is an x value into each function. So for the top one, it's always 2. The output is always 2 in here. But for the bottom one to the right of 7, it's 7 plus 2, which is 9. These are not the same, which means that the limit does not exist.
Okay. If they're not the same.
They're not the same. Yeah. So like to shorthand this problem, I know I'm throwing a lot of information at you. The first one, you look at the first two. The second one, you look at the second two, and you try the x value in the first two, the x value in the second two. And if they're the same, then it's good. If they're not the same, then the limit does not exist.
Okay. That makes sense.
There's always a shortcut for these. I'm not going to bore you or try to make you believe this is important. This is the fastest way to get through
Appreciate
these
that.
numbers. Yeah. Yeah. All right. So the interval in which the function is continuous, this is always what's called an open interval, which means that you're going to use parentheses. Parentheses. You're never going to use brackets, always parentheses. You're setting the part under the root greater than 0. So you're just writing 4x minus 7 greater than 0, and then solving for x. Okay, so we're going to add 7 to both sides. 4x is greater than 7, divide by 4, divide by 4. X is greater than 7 over 4. So if we go to a number line, minus infinity to infinity, there's 7 over 4. It's everything to the right. Oh, to the right like that. So in terms of your interval, it's 7 over 4 to infinity with parentheses. So you have to solve it greater than 0 to get this number, and then because it's greater than 0, greater than this, it's everything to the right. Right forever is infinity. So this is your final answer for this
Okay.
with the parentheses.
Okay.
Next problem here. Okay. One of the best way to do this is to recognize what should we do here? Can you give me a word that describes what 4x plus 2 is?
Function.
It is a function. That's correct. Not the word. Is it, how would you describe the graph of it?
Linear.
It's a line. Yes. So when you're less than 0, it's a line. So somewhere it's either a line or line, something like that. So notice that these two graphs are not lines left of 0. They're the quadratics.
Uh-huh.
These two are lines. Okay. And they're basically the same. They're basically the same, except for right there at 0, something's going on. Okay. So you
Okay.
don't have to like graph it. You just have to like use some common sense that, okay, that's a line, that's a quadratic. It's got to match that.
Okay.
Now to figure out what's going on at 0 is you have to put 0 in for x in both. So for the first one, it's 4 times 0 plus 2. And for the second one, it's 0 squared minus 2 times 0 plus 2. And that ends up being 2. So notice they're the same. And that's good. That means that it does exist. That's not a hole. That's a hole, by the way.
Yeah.
That it's actually this one. So this is the correct graph because
Okay.
the limits are the same.
Okay.
All right. that answers that. The next, and that actually leads to answering the next stuff in here. Let me see here. All right, it says to select the function is discontinuous at. So the graph really helps. The fact that it goes up and then it curves back down and up, but there's no what are called jumps, holes, or vertical asymptotes. Those are its continuous points. Like think of, you probably heard this in previous math class, that if you can draw it without lifting up your pencil, which is the case. You go up like that. That's good. That means it's continuous.
Okay.
All right. Now it says find the limit or limits from the left and right for any values in part B. And you'd say, well, there's no discontinuities in part B.
Okay.
Any questions on that?
Nope. Not so
Yep.
far.
All right. Okay, next question here says find the average rate of change of the function between the given interval. Average rate of change, or AROC, is a given formula. It's f of b minus f of a over b minus a. But instead of b and a, you use these numbers. So it's a is 3, b is 11. So it's f of 11 minus f of 3 over 11 minus 3. And you can see that that's that one there. So if you can remember the rate of change, remember that it's subtraction and that it's got to have numbers. You don't really need to remember the formula. It's going to be in one of the multiple choices. Okay. But then this part, you actually have to calculate the values. You have to actually figure out, like, what is f of 11 and what is f of 3.
Okay.
This is your function. So f of 11 means to put 11 in for x. Square root of 25, which is 5. F of 3 is the square root of 2 times 3 plus 3, which is the square root of 9, which is 3. Typically, if they're asking you to simplify your answer or do a problem like this, it has to work out nice. So if you don't get nice numbers, you will just want to recheck your calculations. And I'm assuming you have a calculator. That's why I'm rushing through these. You
Yeah, yeah.
can do this on your own. So it's 5 minus 3 over 11 minus 3. 2 over 8 is 1/4. That is your final answer for that one.
Okay.
All right, so this one is really, really similar. It wants the same thing. It's another square root function. That's A and that's B. Why don't you jump in here and calculate f of 8 and f of 0 for us, please.
Okay.
And if you need a calculator, let me drop the Desmos Scientific in the chat. It's a good one when you don't have
Okay.
your regular one around.
How do I see? Okay. So I got 5 for f of 8. Is that correct before I go on? And then 1.
Okay, so this becomes 5 minus 1 over 8 minus 0, 4 over 8, which is
Yeah.
1/2.
Okay.
They typically work out kind of nice. Like, they're not going to be crazy fractions typically. I mean, these are all, generalizations,
Yeah.
blanket statements.
Yeah.
Okay. All right. So let's see. I'm just kind of looking ahead here. I mean, probably we'll need to extend the lesson a little bit to get this in. So, you can just kind of start thinking about that if you want to do that or not.
Yeah,
Um,
to get to all of them, then yeah, we can do
right.
that.
All right. So suppose the position of an object moving in a straight line is given by this function. Find the instantaneous rate of change. So the difference between average and instantaneous is there will be a limit, and it's a limit as h goes to 0. So you can see the only one that has that notation is this right there. That one right there. So we know that that is the correct answer. Now, in terms of actually finding it, so there's this whole limiting process that we could do. We don't want to do that. Okay. Now, you said you've got a calculator. There's a couple of ways you're going to learn your derivative rules at some point, but your calculator will do derivatives for you. It's called n-deriv, and I'm going to show you that here. It doesn't do everything. So just keep in mind, it just does the numerical ones here.
Okay.
Uh, but this, again, this is a shortcut to help you get through this class. So n-deriv is under math, right there. You have to enter the function with x, always x squared plus 5x. Yours may look a little cleaner. This is an old piece of software that I need to update, but have not. And then you put the x value, which is 1. You hit enter. Oh boy, comma, 1, enter. And there's your answer. All right, so I would recommend trying that on yours if and when you get your calculator around to
Okay.
just verify that. Now, not actually do it like we're not going to do this. We're not going to do this limit by hand, but we are going to actually write down what the so the 1 comes from right there. We are going to actually talk about how to actually calculate the derivative. There's a bunch of derivative rules. So I think in your next part of your course, you're going to learn that it's 12t plus 5. And then you put 1 in for t. 12 times 1 plus 5 is 17, like that. All right. Yeah, so the next problem here, it says, again, find the instantaneous velocity. That's the derivative. Now, because it's at a specific point, you can use the calculator to do that. You can use the n-deriv again. We're going to do it by hand. Well, kind of. I'm going to give you the derivative here, which is s prime of t, and you'll learn these rules in the next chapter. Um, you'll have them like when you get this problem on your test, you don't have to do limiting. You can just take the derivative and put 2 in for the derivative. And when you get your test, you'll know these rules really well, so it won't be an issue. You're just putting 2 in for t. This ends up being 12 minus 4, which is 8. Or you can use that n-deriv on your calculator. Yeah, questions or thoughts on that?
No, that seems like
Okay.
good.
All right. So yet again, another problem where you could use n-deriv. The reason you used n-deriv is because it wants the derivative at a point 1, 2, and 3. However, your calculator will not give you the actual algebraic derivative. So that's why you have to learn the rules. So I'm going to give you the rules here, I'm going to give you the derivative, minus 2x plus 8. You will learn that rule here shortly. What I'd like you to do is evaluate the derivative at each of these points, at 1, 2, and 3. And not super complicated, but um, take a look at that.
Okay. So just at 1, 2, and 3.
Yes.
Okay.
1 in for x, 2 in for x, 3 in for x. Should notice a pattern as well.
Okay, so for 1, I got 6.
Okay.
And then for 2, I got 4.
Okay.
And 3, I got 2.
Very good. The reason there's a pattern is because this is a line or linear, like you mentioned earlier. You shouldn't be surprised by that.
Okay. 6.
All right, so next one here.
Sorry, I didn't get the first part down. If you got it.
Okay.
Sorry about that. Okay.
Good to do it as we go here rather than getting to the end and being like, oh,
I
where's
know. I switched to the calculator. I was like, oh, I didn't write any of that down.
all
Okay.
right, so a couple things here. This is called, again, this is an open interval. And what that means is that you exclude the endpoints. Like you don't look at the endpoints. Because the derivative, the function is not differentiable at the endpoints. But that's a separate thing here. So here's what we're looking for. It's not differentiable in the following situations. A hole. So do you see a hole?
Yeah.
Okay. And we want the x values. So when it says x equals, I must not have snipped uh yeah, I must not have snipped like where is it just x equals in a box for
Yeah,
the
it just
answer?
says the function is not
Okay.
differentiable at x equals
Okay,
box.
so we want the x value there, which is 3. So at a hole is thing 1. Second are jumps. So there's a jump here from this hole to there. So you could argue it's not differential because of the hole or because of the jump. It doesn't matter. It's just not differentiable. And again, it's the x value that we care about, never the y, never the y. The third thing is what's called a cusp. Cusp is there at 1. That's a cusp. I don't make these up. This one does not show what's called a corner. A corner would look like this if the graph were to literally hit at like a corner, right? That's a corner. We don't have any in this graph, but it could be a corner. And then vertical asymptotes, which we do not have any in this graph, but those are other things to look out for. All right. So this thing is not differentiable at 1, 3, and 5. Just to be safe, I'd probably put them in order.
Okay.
No comma after 5.
Okay.
And this list is only here to because you might see a different graph on your test.
Okay.
Couldn't
Yeah.
couldn't tell you.
Okay.
All right. Next one here is okay. All right. So it's the same thing as the previous one, except you don't have the graph. But you don't. This is not a real function. This is a mixture of functions that they made up for that. So when you get something like this, which is a rational, it's got a top and a bottom, you only care about where the bottom is equal to 0 because you're not allowed, not okay to divide by 0. So you basically just need to figure out where is the bottom equal to 0.
Okay.
Top, you don't care about,
Okay.
just the bottom.
So -4.
Yeah,
Okay. That's easy enough.
yes. I like problems like that.
Yeah.
There is a few other things that could happen, but we'll just assume that, maybe dangerously assume that your question will be like that one. Okay. All right. So the next one here, let's actually do part B first. If you got it on your screen, you can see it says part B is where it's undefined, where the derivative is undefined. that's the same thing as not differentiable, undefined. So basically I'm asking for the same list here. Like, what would you call this? And left per corner is fine, but there's a problem right there. It is not differentiable right there. What is the X value?
-3.
-3. So to answer part B, and we're going out of order. Um, Sometimes I do that for clarity.
Yeah,
Part B is
-3.
-3. Yeah. Okay. Part A, determine where the derivative is 0. So when you're looking at the graph, you're looking for what's called a horizontal tangent, but there are 4 things that you're looking for. You're looking for a peak, you're looking for a valley, you're looking for, I don't know what to call this, but that's a horizontal tangent there, and then going the other way. These are the 4 possibilities. Peak, valley, and I don't know what to call these. It's like a plateau maybe. Not really. I mean, a plateau is, that. Um, so the only one is right here. And we want the X value again. Always the X value. It even helps here. It says the X value. So make sure you're choosing the X value, which is -1.
Okay.
There could be more than one. That's why it says to use comma to separate answers, but in this one there is not. But these are the things you're looking for: peak, valleys.
And those.
All right. Okay. Now, this next part is way more complicated. I hate that they do this. It's so hard when they mix this stuff in because you're just barely understanding like what is a derivative, and now they're
Yeah.
asking about graphs. So this means increasing. It means the graph is going up and to the right. Okay, so we're gonna look at the graph. Where is it going up and to the right? And it's going up and to the right in a lot of places here. I'm gonna try to highlight it. This is going up and to the right, and then it's going up and to the right.
Mhm.
So do you hike? You ever been on a hike?
Yeah.
Okay, so this is where you're going uphill.
Okay.
Increasing as you're going uphill. If you need to, you can draw a little stick figure. I'm going uphill. Again, it's the X values. You care about the X values, not the Y values. X, X, X. So this one is increasing from -infinity to -3. That's this first yellow, comma, -1 to infinity. Even though the yellow is going up, this infinity over here is to the right forever. These are the X values.
Okay.
That's the answer to part C.
Okay. So I just type in, do I have to do the U between them or just,
No, yeah, so it says use a comma. Just cut off here.
oh yeah.
It's a good question because it's not a domain.
Okay.
Uh, it's so confusing. They should be more consistent, but they're not. All right, so now where it's decreasing is when you're going down and to the right.
Okay.
So typically, if it's not increasing, it's decreasing. That's why I go back to the analogy of hiking. When you're hiking, you're typically going uphill or downhill, even if it doesn't feel like it. You typically are. So you again looking for the X values here from -3 to -1. It is, you're going downhill. You're decreasing.
Okay. And will it ever be like constant?
Good question. I don't think so in this class, but like in your pre-calculus class, it would be. So, this is the typical increasing. Let me change this. Wow, I didn't know it did that. Okay. Increasing, constant, decreasing. But I think you're only going to see increasing and decreasing in this
Okay.
class.
Sounds good.
All right. Last part here is Sketch a graph of the derivative. Boy, that is really, they're asking you to do a lot. Okay. Oh boy. All right. So your derivative, let me do it down here. Let me make this smaller, smaller. Okay. So you take these places where there's either a problem or the horizontal tangent, and you kind of dot them down to your derivative graph. This is your derivative graph down here. And these create like windows or sections. There's section 1, which is the one's going up and to the right, section 2, which is going down to the right, section 3, which is going up and to the right. So what is really unclear, we'll try to make it clear, is that the derivative graph is the slope. It's the slope of the original function. The slope of this function right here is approximately, looks like it's 2/1. So in your derivative graph, it's a line at 2 because it's got a slope of 2. The next one has a slope that is changing. It's getting, it's negative, less negative, closer to zero, closer to zero. So it has a really, it's like it looks like that because it's below the x-axis. Below the x-axis means negative slope. It's okay if this doesn't make sense. Above the x-axis means positive slope, like that. So you're looking for a graph that looks something like that, which appears to be letter C. You would really want to spend a lot more time on this to get it down. But I get it. We don't have the time. We're not, not trying to learn this the way you would learn if you're taking like calculus 2. But what you're looking for, this is the key part. The key part is this one on the left, the fact that its slope is 2, so it's a horizontal line at 2. That's a big giveaway of it. I guess they all have that except for B, so it's not super helpful. All right, let's just move on. Give you a better explanation when you get closer to the test if you need it. They do a test review, I think, in this class, which is really good because it's the test questions you're probably going to see when you take it in person. Okay, so the question here is asking like which one's the original function, which one is the derivative. So it's hard for me just not to give you the answer because it's you really need some explanation first. But this point right here is a horizontal tangent. And then that corresponds to this right here on the derivative. So wherever there's a horizontal tangent and there's only one, that has to be a derivative here. A derivative on the derivative is 0. So based on that, I'm suggesting that y1 is the original and y2 is the derivative. Okay, now let's just go a little bit further and see if that's the case. I'm going to highlight a section of what I'm calling the original function. Is this increasing or decreasing in the yellow?
Increasing.
Increasing, yeah. So that's increasing, which means that the derivative is above the x-axis. So is y2 above the x-axis there, where I'm pointing at? Just is it above? The answer is yes, it is. It is above. Now in this next part, over here to the right, it's decreasing. Decreasing means that it's below, the derivative is below the x-axis. So is y2 below the x-axis? Yes.
Yeah.
So y1 is the original, y2 is the derivative. Like, I don't know if you like these kinds of questions on the test because there's not, I think that's what I said. Y1 is the graph. Yeah, y1 is the original. They're not like, they're pick one, but you got to know one thing. You got to know that where the horizontal tangent is, does that correspond to the zero on the other graph? And it does.
Okay.
All right. Did we miss any questions?
Nope, we got them all.
Okay. Now, just for, thinking about scaling this, like, don't feel like we can always do 18 questions in whatever, 50 minutes ish,
Yeah.
like these are not as difficult as future ones. I
Okay.
also did a lot of the explaining, which I'm happy to do. So just keep
Yeah.
that in mind that,
Yeah.
you know, you may find that